In this video, I'm going to talk about the negative rule of exponent. Now, another useful result occurs when we relax the condition that m greater than n in the quotient rule even further. Now, for example, can we simplify the expression? Let's say h exponent 3 on h exponent 5. Now, when m is less than n, where here m is 3 and n is 5, which is when the difference of m minus n is negative, we can use the negative rule of exponent to simplify the expression to its reciprocal. Now, we divide one exponential expression by another with a larger exponent. So we are going to use the example that I just wrote here, which is h exponent 3 on h exponent 5. That's what we are going to use. So let's simplify this and see. So with h exponent 3 and h exponent 5, we can also write it in the form of h dot h dot h, which is 3. Then on h dot h dot h dot h dot h, which is 5 down. So let's cancel out. When we cancel, we should get 1. This cancel this cancel. Then we are going to have 1 on h dot h, right, which is 1 on h exponent 2. Now, if we were to simplify the original expression using the quotient rule, we will have something like so. Using the quotient rule, we can quotient rule, right? So we will have maybe something. So let's say we have the expression h exponent 3 on h exponent 5. We will have something like h, which is the base, then exponent 3 minus 5. That's what we are going to get. Then we get h exponent negative 2. So putting the answer together, we will have h exponent 2 should be equal to h 1 on h exponent 2. So this is the truth for any zero number or any variable representing the non-zero real number, right? So a factor with a negative exponent becomes the same factor with a positive exponent if it is moved across the fraction bar from the numerator to the denominator, or vice versa. So if you should have something like maybe a exponent negative n, we should get something like 1 on a exponent n, and also a exponent n should be 1 on a exponent negative n. That's what we are talking about. So if we have shown that the exponential expression, which is the a exponent n, right, is defined when n is a natural number, 0, or the negative of natural number. So that means that a exponent n is defined for any integer, right? So also the product and the quotient rules and all of the rules that we have looked at will hold for any integer n. So now let's take the main rule here. So with the negative rule of exponents, we have for any non-zero real number a and a natural number n, the negative rule of exponent states that a exponent negative n is equal to 1 on a exponent n. That's what we are talking about. That is the negative rule of exponent. Now let's solve some real examples here. Now we are going to write each of the following quotient with a single base. So our first example is we have theta exponent 3 on theta exponent 10. So how do we do this? So using the quotient rule, using the quotient rule with the same base. So we have theta exponent 3 minus 10, right? Then when we subtract that, we should get theta exponent negative 7. And When we do that, we should get 1 on theta exponent 7. That's the answer for the first one. Now you can pause the video and try to do the B on your own. So if you have done it, let's look at the B. So with the B, we have z exponent 2, which is z squared dot z. Then we have on the denominator part, we have the z exponent 4. So how do we do this? So with this one, we just, the top one, we have to simplify the numerator first. So with the numerator, we are going to have z 2 plus 1, because there's 1 here, and the down we have z exponent 4. So we have z exponent 3, then z exponent 4. Using the quotient rule, we have z exponent 3 minus 4, then we get z negative 1. Then we have 1 on z. So this is our answer for the B. I hope you got it. Now let's look at the C. With the C, we have the numerator to be negative 5 exponent 3, or in one bracket exponent 4. Then the denominator, we have negative 5 t exponent 3, or in one bracket exponent 8. So you can also pause the video and try to do this on your own. So with this one, we have the same base as negative 5t, then 3 here. Then we have 4 minus 8 as the power. Then when we do that, we should get negative 5t3, negative 4. So with this one, we'll get 1 on negative 5t3 on exponent 4. So that is that for the negative rule of exponent. Very easy. Now let's look at another rule. That's we are going to find the power of a product. Find the power of a product. Now, to simplify the power of a product of two exponential expression, we can use the power of a product of exponent, which breaks up to be the power of the product of factors into the product of the powers of the factors. It's kind of strange statement, but I'll break it down for you. For instance, consider so let's say we have maybe PQ, right, exponent 3. We beginning by using the associative and the commutative properties of multiplication to regroup the factors. So how do we do that? So with this one, we will have PQ. So there's no dot here. So that's PQ here, right? Then we have another PQ. So with this one, we have 3 factors. We have 3 factors here. So when we break them down, we should have PQ, right? Then when we group them, we should have P, then Q. So here we have 3 factors. Here too, we have 3 factors for the Q. So when we group them together, we should get P exponent 3 dot Q exponent 3, right? So in other words, PQ exponent 3 is equal to P exponent 3 dot Q exponent 3. That's what we are talking about here. So let's take the rule. Now, for any real numbers a and b and any integer n, the power of a product rule of exponent states that if you have a, b exponent n, which is equal to a exponent n, b exponent n. So a, b, or in one bracket exponent n should be equal to a exponent n, b exponent n. So that is for the power of product rule of exponent. Now let's look at some examples here. So I'm gonna clean this one. So with our example, we are going to simplify each of the following product as much as possible using the power of product rule, right? So we have our first question to be a b squared, or in one bracket exponent 3. So how do we do this? Let's simplify that. So I'm gonna use red. Then we go. Okay, so with this one we're gonna have a exponent 3 dot b squared exponent 3. Then we'll have a exponent 1 dot 3 dot b exponent 2 dot 3, and we'll have a exponent 3, b exponent 6. That is that for a. Now b, you can pause the video and try to do this on your own as well. So with the b, we have 2t exponent 15, right? So with that, we are going to have 2 one bracket exponent 15 dot t exponent 15. Then we have 2 15, then t exponent 15. Then we should get 3, that's 32,768 t 15. That's what we should get for b. Now let's go at c, the last one. So with the last one, we have negative 2w exponent 3, or in one bracket exponent 3. So with this one too, we go with the same thing that we are doing for the previous one, we did for the previous one. So with this one, we have negative 2 exponent 3 dot w exponent 3 dot 3, and we should have negative 8w exponent 9, and that's the answer for the C. So this is the end of this video. I'll see you in my next video. Thank you for watching.